So this is just a quick intro into the TRVs. They're the technical rescue vehicles that Fire Rescue have, 4 of them currently in service. They're designed to have effectively like a 2-hour overlap based on where they're positioned. Blacktown, Liverpool are the 2 within the GSA. Blacktown generally has a northwest area of responsibility. Liverpool will have an east-south, and then Blacktown crosses over with Lambton up at Newcastle, and Wollongong and Liverpool will cross over down south. Between the 4 stations, the trucks have the same inventories. However, there are some slight capability differences which fall under State Rescue Board accreditation, and with specific units which were in existence pre the trucks being put into place. So they came about to bridge a capability gap between, historically we have rescue pumps. That's a fire truck with a primary rescue capability. We then had heavy rescues that has no real firefighting capability. It's primarily used for rescue purposes, but then has more equipment than a rescue. And then it went from there to USAR-1, which is what I mentioned earlier, being a semi-trailer, predominantly designed around major structural collapse within the state of New South Wales. USAR-1 in recent years has been deployed as far as up to the Northern Rivers a couple of years ago in the back of the flooding events, where they had whole structures that slid down effectively at the side of mountains where body recoveries were required, and those buildings had to be stabilised to do that safely. The TRVs are designed to bridge the gap between the heavy rescue and USAR-1, to have equipment, some of which USAR-1 carries, but is manned 24/7 across stations that are permanently staffed. USAR-1 can be activated at a moment's notice. It is located at our ESA, the Emergency Services Academy at Orchard Hills, but depending on what time of day that is, will dictate how quickly that is actually rolling out to an incident. Our general parameters around the timings of USAR-1 being deployed is 20 minutes plus a minute per kilometre to get to where it needs to be. So the capabilities that are focused around the tech rescue that are beyond what a typical heavy rescue is partial structural collapse. That's talking about lightweight structures. We're talking about, brick veneer houses and things to that effect, not skyscrapers. Trench rescue, large animal rescue operations, complex transport, structural stability, where we have a leader sentry to monitor movement, bariatric rescues, and then Liverpool, Blacktown and Lambton are the vertical rescue accredited units. Wollongong isn't VR. Down there it is, I think, police might be the vertical rescue capability down in the Illawarra. Lambton and Wollongong are both Swiftwater accredited units, or I think it's been now referred to as in-water, floodwater rescue in those areas. So, partial structural collapse, it's designed for lightweight, generally speaking, single-storey constructed houses. However, we do get turned out to, most newly built houses, anything from the 90s onwards, generally is a 2-storey house these days. And we do have the ability to shore them up to a point, depending on, normally it's a height limitation with the timber that we carry on those trucks that are a problem. From there, we will call USAR-1, which turns up with timber lengths that are up to 5 metres, where we can put in shoring to support suspended brickwork and upper levels of houses. Primarily, it is to create a safe workplace. So if we have a car into a house, persons are trapped, to create a safe environment for the fireys and paramedics and doctors to treat that patient while the extrication then takes place thereafter. So with the power shores that we were showing you earlier with that large vehicle rollover onto the Bobcat, we also use those for structural stabilisation. They're things that we can put in place really quick to then affect a rescue. And then when time's on our side, we will then use timber to substitute, put those in place to grab our gear back and walk away from the site. Trench rescue, that falls under that high risk, low occurrence type work. That is a thing. It is very labour and resource intensive, those types of incidents. Anecdotally from other states' fire services, more often than not, these things end up becoming more like a body recovery type nature in their work. And then different parts of the state have very different soil types that we end up coming up against too. So over this side of Sydney, it's pretty consistent. When you speak to fireys that in WA, very sandy soil consistencies. They have to use different methodology to what they're dealing with over there. This side of the Great Dividing Range, we're generally dealing with essentially clay, and then as we get more to the coast, it gets a bit sandier, more sandstone and stuff that we're involved in. LARO or large animal rescue. Sometimes these things they cross over the nature of what that work is. We haven't had too many incidents where it actually has much human medical intervention required. It is generally purely an animal that needs the assistance. These sometimes end up coinciding with large weather events as well. So we'll actually have in-water flood teams working kind of hand in glove with teams from the tech rescues, because the environment they're now operating in is a floodwater environment. Complex transport. It's normally things where we've got all the equipment and then some to do with our typical RCR type work. Where it really shines is more the higher volume of high capacity lifting and winching capability when we're dealing with essentially heavy vehicles. Earlier I mentioned about an elevated work platform. Not only is it very good for ergonomics when you've actually got to operate from a high point, especially when dealing with heavy tools. Some of the best use that I've seen it put to is when we're working very closely with the medical teams on scene, that we can position this in a way that gives really good access to the patients whilst still allowing very good rescue access. And that way we have really firm demarked areas of operation where things can keep moving forward in an outcome of a quick extrication and getting the patient off to hospital, opposed to times when we have a really tight workspace where we've really got to work in and out between a rescue and a medical perspective, where we've got to essentially take turns at who's in to do their next part of the task. Some more examples there of the use when it comes to the heavy vehicles and stabilization. It has a winch on the actual front of the vehicle as well. It's generally speaking, we're only really using that if sometimes there's benefit to actually removing the car off what it's wrapped around. There are times when the car is embedded into a power pole or a tree, and that's actually where the side that the patient's on as well. The tree, that pole, that effectively becomes like an immovable force. So we actually need to be able to remove the car from that area to actually gain the access and to release the patient successfully. That's the leader sentry there. So it's essentially a laser measuring device set up on tripods. It feeds back to a control centre. From there, we set thresholds. Between the two different lasers, we can set different thresholds for each one. As a general rule, we're trying to get to the highest point of a structure, being that, once something starts to pivot, that's where you're going to get the greatest movement, the quickest to get the earliest point of warning. Different construction types have different nuances, being, double brick type masonry places can have sections where the walls effectively kind of waterfall down and just topple over, opposed to having a tilt slab that will pivot at the base and the whole thing will come crashing down. When these things are set up, sometimes you actually have to put them in an area that would be in a collapse zone, but then the length of the cables allows us and the operator to be out of that area. So we can kind of enhance our situational awareness of what's going on, and having an early warning system. And when these things are set up, generally we will have to communicate that with everyone who's on that incident ground to go, pretty much, if this alarm goes off, it just means get out of that area immediately so we can reassess what's going on before anyone re-enters that area. Other times, if we have enough people on scene, we will have someone manning that control box permanently, and they will actually have an air horn. So, and this would be communicated to everyone on scene, being that 3 horn blasts would be the signal to evacuate, not the actual device going into an alarm. With our bariatric lifting, we just have a range of lifting sheets, and we have a bariatric Stokes. The bariatric Stokes is great, except it's too wide to fit through most doorways in most common houses. So it's last week we had someone we had to remove out of their house to get them to hospital. So we actually had to cut a section of their wall out to get them out of the house. And then the hospital rang us a week later to go back to open the wall back up to put them back in the house. In that case, that Stokes was really good because it's a solid stretcher. It bridged really well to the gurney out of the house. But how we tried to use that inside the house itself, it's no good because you can't get it around corners, you can't get it up the hallways and out of doorways. And then that's where the lifting sheets would come into play. More often than not, we're using this with the bariatric ambulance from ambulance. So it's normally in cahoots with the things like the elk and the hover mats, and a combination of all those tools to get the person out and off to hospital. We have pretty comprehensive vertical rescue equipment and skill sets now. Of late, ambulance and fire rescue have been kind of cross-pollinating on their training courses, and that's to try and get all of our jargon in lockstep with one another. So when we have scenes, the way that the scatties might rig could be slightly different to ours, and vice versa. And so it's more to get that cross-pollination of information, that what each service is doing is perfectly fine and safe, but it's having that awareness to trust it, and also to get the vocabulary around it kind of in lockstep. So when on those scenes, everyone's speaking the same language in a literal sense. And then, we've got Wollongong and Lambton have their in-water capability. They've got their Archangels, and on top of the TRVs, they've got a gantry for the boats. When a weather cell comes in, that they'll have those boats inflated, strapped on, ready to go to respond. So on top of that, there's a range of mobile lighting sources. We have some really good area lighting. It's stuff that they actually use in roadworks when they're doing nighttime roadworks. Big balloon lights. So when there's protracted rescue operations at night, we can set up very effective all-round area lighting that gives off very minimal shadowing as well, just due to the way it's diffused. And back to what was being discussed earlier around heat stress, there's an awning that comes out from it, and we have quick shades that we keep on, a 3x3 metre quick shades. These have been used before by doctors and paramedics on scene when they've effectively set up a roadside operating theatre to start doing surgical type intervention pre-transportation. So that's about it in a nutshell about the capability of the vehicle. Thought, if there's no questions at the moment, we'll go out and actually have a look at it and have a walk around so you can see the different range of equipment that's on it. And then if there's any questions from there, we go from there.
Just